Hello everyone, I'm Pratik Srestha. I'm a recent graduate from Miami University. Today I'm here to present a case study on blockchain-based anonymous reviewer incentive token. Publishing academic research is crucial for scientific progress. Manuscripts are reviewed by experts to ensure credibility, validity, and novelty. Researchers submit their work to journals or conferences where it is evaluated for its significance before being published. Publication outlets often struggle to find reviewers. A cyberpsychology journal report from 2022 revealed that they contacted 22.6 reviewers on average just to secure two reviews. Only 14.5% of invitations are accepted, whereas many are ignored. This delay hampers the overall review process. The primary issue is the lack of incentives for reviewers who invest significant time without any recognition or reward. While some publishers offer compensation, these rewards are typically platform specific and rely on centralized systems which fix data loss from outages or closures. We propose a public peer review framework combining blockchain with an off-chain database to address these challenges. Blockchain ensures transparent and immutable storage of records. This allows us to design permanent publisher-agnostic incentivization schemes, but it provides flexibility with support for various peer review processes, anonymity preservation, and venue-specific incentivization models. We also present the implementation and evaluation of the proposed design to demonstrate its feasibility. We started with a preliminary round of interviews to gauge system requirements. We conducted open-ended interview with 10 individuals from the scientific community. The participants were experienced researchers who had served in the role of reviewer, associate editor, and editor-in-chief. These interviews helped identify system requirements by understanding the motivating factors for reviewers, the challenges that they have faced during the peer review process, and their perspective on what will encourage more active participation of researchers to peer review others' work. We found out that reviewers are mostly driven by intrinsic satisfaction of learning about the current research and obligation to support fellow researchers. Early career researchers emphasize the importance of reviewing papers for tenure and promotion. Editors often have difficulty finding qualified reviewers. One participant noted that out of 30 invitations, only three accept on average. Even those who do not who accept the review a request often submit late or not at all. Reviewers show appreciation to incentives in the form of public recognition from outlets as well as renewal credits for publication-related fields. From the interview findings, we identified three main design requirements: incentives, flexibility, and trust. The incentive and flexibility requirements lead to incentive engineering as a design principle. The system should be able to support different forms of peer review model and provide flexible incentivization options. For the system to be trustworthy, the collected rewards should be perpetual regardless of the journal or conference venue and their underlying system. There should be transparency about the system architecture for creating, distributing, and maintaining incentives. To incorporate these design principles, we have implemented the following features. Tokenization allows rewards to represent varying values such as recognition and redeemable tokens. The need for transparency and perpetual rewards leads to the use of blockchain for its immutable, decentralized, and distributed features. To preserve the anonymity of authors and reviewers, all the confidential information is stored in an off-chain database. A dedicated file storage is used for reduced storage cost and improved throughput. Now let's move on to how the system is designed. We have three users: author, editor, and reviewers. The web interface interacts with the frontend that connects with IPFS for secure and tamper-proof file storage and MetaMask for user authentication. The backend is built using Node.js server that provides a REST API to interact with the SQL database. These models interact with Ethereum network using Web3 library and Infura. In our platform, authors submit their manuscript using the web interface, which is uploaded to IPFS. Editors can now verify that the paper meets minimal standards and assign qualified reviewers. They can also provide a review deadline. Reviewers can then view the review invitation and submit a review report. Upon review submission, a flag is set in the database to indicate that the reviewers will be assigned reward tokens. Once necessary reviews are submitted, the editor makes publication decision, which can be viewed by the authors. Each month, eligible reviewers receive reward tokens directly under MetaMask wallet. We explored two tokens incentive model to accommodate varying reviewer motivations. Solvent tokens are non-transferable public certificates of acknowledgement that represent their recognition for the reviewer's contribution. Fungible reward tokens are transferable tokens that are redeemable for different services such as subscription and submission fees credits. The tokens are allocated dynamically depending upon the journal settings and whether the reviews are submitted in timely manner. As previously discussed, reviewers are not immediately rewarded upon submitting a review report. Instead, a flag is activated in an option database table, signifying that the reviewer has fulfilled their tasks and is eligible for compensation. Each month, the web server queries database to obtain the list of reviewers who needs to be rewarded. All the reviewers are then rewarded Solbound tokens. The distribution of fungible reward tokens is dependent on the specific journal policy. Now let's view a video demonstration of the project. This is the landing page for Review Rewards website named as Miami NFT Journal. By clicking the Connect Wallet button, users will be able to log in using their MetaMask account. We have made multiple user profiles within a single MetaMask account for easy viewing for this demo. Let's first log in as an author. An author can view the manuscripts they have submitted and submit the manuscript easily by clicking the Submit Manuscript button. They can select the file they want to submit and select the journal they would like to submit to. Once it is submitted, they can view in their dashboard. Let's log in with an editor account. Here, the editor can view the manuscripts that has been submitted to the journal and assign reviewers. I'm assigning Kavli as a reviewer and setting a submission deadline for them. As you can see here, they can view the reviewers and the status as well. Editors also have access to the settings page where they can view different reward options. The reputation tokens are assigned to all the reviewers that submit to our system. Editors have the flexibility to enable or disable the utility tokens and determine the amount of tokens that the reviewers will receive based on their timeliness. Now moving on to the reviewer's profile. Reviewers can again view the manuscripts that has been assigned to them for review. Reviewers also have access to the reputation page where they can view the tokens that they have accumulated to date. Right now, this particular reviewer has 3 reward tokens and 1 reputation token. The reviewers can use the Submit Review button to fill out some necessary information about the manuscript that they reviewed and then upload their reviews as a TXT file. The system follows double-blind peer review process, hence they won't have any information about the author. Now, the editor can view submitted reviews and make informed decision whether to accept or reject the paper. Once they are ready, they can submit their decision along with editor notes. The author will now be able to view all the details regarding their paper. They can view the reviews, the editor's note, and also the paper acceptance status. Now let's log in as the reviewer and go to the reputation page to check the reward tokens after submitting a review. Before submitting the review, reviewer had 3 reward tokens and 1 reputation token. The system periodically checks for new reviews submitted to the journal. If new review submissions are found, they will be processed and reviewers will get assigned tokens based on the journal's policy. As we can see here, the reviewer has now received the expected tokens. The reviewers can view the tokens in their MetaMask account as well, which will make it possible to use the tokens outside of the system in future. So we evaluated the system based on its performance as well as user satisfaction. We measured the gas consumption across varying load factors and also for maintaining varied amount of tokens. The gas cost was consistent for most methods under varying load. This ensures that the gas cost will be predictable and minimizes the risk of unexpected fails. Also, as expected, cost of bulk minting is directly proportional to the number of tokens minted in a single API call. This table presents the average gas price for the smart contract methods in different blockchain networks. As expected, smart contracts associated with bulk minting consume the highest amount of gas. We evaluated the latency or the delay in response time by load testing the prototype with 50 concurrent requests per second. Smart contract methods have the latency between 400 to 700 milliseconds for most calls. Bulk minting 3 tokens takes about 673 milliseconds in average. The average latency for the file transfer and API call for SQL queries are also below 600 milliseconds. We demonstrated the prototype to the initial set of interviewees and asked open-ended questions regarding the design system. All agreed that the system is intuitive, offers benefits to the reviewers, and could make the review process more efficient. All the participants felt that the offered incentives were adequate to motivate the reviewers. Majority of the participants were satisfied with the flexibility and trust requirements as well. However, one participant commented that they would love to see the system integrated with the existing peer review platforms. So to summarize, this research tackles the challenge of finding expert reviewers by leveraging a hybrid on-chain, off-chain database system. The two-token incentive model is designed based on the interview with experts that offers recognition as well as redeemable credits for publication-related fees to reviewers. We evaluated the system performance as well as the user feedbacks to determine if the system will be good enough to and satisfy the system requirements. In future, review quality metrics can be enhanced with factors such as length of the paper being reviewed and the experience level. Integration of the framework with existing peer review systems will help widespread adaptation. Further research needs to be done on establishing base guidelines and rules for secondary distribution. Thank you.